So Unit 3 is bright green. All right. We're going to start with day 1 today, which is graphing quadratics. All right. If you guys look, day 2 is also graphing quadratics, and day 3 is graphing systems of equations. All right. We have 3 straight days of graphing, and then you have a mini quiz on those 3 days. Any questions? After that, well, after the mini quiz, you have a lesson, and then another lesson, review day, and then the test. For you guys, the test is going to be on December 2nd for now. Okay? So if the schedule goes accordingly. Okay? All right, so let's talk about graphing quadratics. So a quadratic means that your biggest exponent is 2. So the most basic equation, or your parent function for a quadratic, is y equals x squared. Okay? So here's the great part. Anytime you have a y equals, you can plug it into your calculator. So let's do that. Let's go to our calculators, and we're going to put in x squared. Okay? Hit graph. Let's see what this looks like. Yeah? It is a U shape, and that is a parabola. Okay? All right? So y equals x squared. All right? So if I want to graph this, you can go to second graph to get your points. All right? Here are some points. No, actually, you know what? I don't need this. I'm going to ask you guys. So I can do 0, 1, 2, 3, -1, -2, -3. Those are like my standard x values for when I graph, right? When I check on the table in the calculator, when I go to x number equals 0, what is my y value? When my x number is 0, what is my y number? 0. Okay. How about for 1? 1. How about for -1? +1. How about for 2? 4. How about for -2? 4. And how about 3? And -3? 9. So, just in case, okay, if you guys are graphing this without a calculator, basically you're plugging in these x numbers into your equation. So 0 would be 0 squared. What's 0 squared? 0 times 0? 0. 1 squared. 1 times 1? 1. -1 squared. -1 times -1? 1. All right? Like, that's where we're getting all these values from. Now, let's go and graph this. We can't go all the way up to 3, 9, and -3, 9. Which is okay. So let's talk about the different forms of quadratic equations. So there's the vertex form, and this is the one that you guys are probably the most familiar with. Y equals a times x minus h squared plus k. Yeah? This is where we can get the vertex, we can get our transformations. And then we have standard form, which is y equals ax squared plus bx plus c. And this form we like, when we have to use the quadratic formula, right? And then there's the intercept form. Okay. So now we're going to talk about the important features of this parent function. So the domain. Remember, the domain is looking at the graph from the left to the right. Yes? Put a star by it because the domain is always going to be the case no matter what. Okay? No matter what transformations or what happens to the quadratic. Look at this quadratic. From the left to the right. You have an arrow going to the left. Where are you going? Negative infinity. You have an arrow going to the right. Where is that going? Yeah. So, what is the domain? Yeah. Negative infinity to infinity, all real numbers, right? And a parabola, which is what that U-shaped graph is called, right? A parabola always has a domain of all real numbers because you have an arrow on the left and an arrow on the right. Okay? Now let's talk about the range. All right, so if I look at this graph, so from the bottom to the top. Thank you. All right, from the bottom to the top. First off, if I'm down at negative infinity, does my graph even exist? No, because I don't have arrows that are going down. Where does this graph start? 0. And it goes to where? All the way up to, good, thank you. All right, so from 0 to infinity. But guys, at 0, there's a closed circle. So what? All right, so is this continuous? Yes. Yeah. Are there any holes or breaks or gaps in this graph? No. So it's continuous. Right? Now, is this one-to-one? You know, yes? Let's see. So if I want to see if it's a function, then I have to use the vertical line test, right? So does this graph hit this line only one time? Yes, right? So that's a function. But if I want to check and see if it's one-to-one, I have to use the horizontal line test. No, because this graph hits this line in 2 different places, right? So 1-to-1, no. All right. Where's my vertex? Good. 0, 0, that guy right there. Vertex is 0, 0. Now, for the axis of symmetry, right? Anyone remember this? Axis of symmetry? We talked about this with absolute value. It's in the name. X is. X is. X equals. Please remember, it's X equals. And then, Carlos, you're right, 0. It's the X number from your vertex. Is that what you were asking, Jenny? Because you're not talking about like a solution, just talking about an equation. All right, so let's talk about minimum and maximum value. Guys, this graph right here, this parabola, does that have a minimum or a maximum? Minimum? Anybody else? Minimum? Yeah, it is a minimum. You see this red dot, the vertex? It is a minimum because it's the lowest point of this graph, right? So, if you look at this next box, your minimum is also 0, 0. And in this box, let's make a little note for ourselves. Your minimum or your maximum is always going to be the same as your vertex. Okay? Same as the vertex. Here's the thing though, guys. If I have a minimum, can I also have a maximum? So if I look at this one, here's a minimum, but do I have a maximum, like the biggest point? No. You can only have one or the other. So if you have a minimum, there is no maximum. Okay? All right, so let's look at increasing, decreasing, and constant. So I'm going to go back and look at my graph here. Guys, what is my axis of symmetry again? X equals what? 0? Okay, so then that means at x equals 0, that's where my line goes. Right? That is the line that splits this graph in half. Okay? All right, so let's take a look. From negative infinity to 0, I have negative infinity because I have an arrow going to the left, right? What is this graph doing? Decreasing. And what is it doing from 0 to infinity? It's increasing. So there you go. Increasing from 0 to infinity, decreasing from negative infinity to 0. And remember, you never use brackets here. It is always parentheses. Okay? Is there a constant interval? Is there a point where it goes straight like this? No. So none. You're never going to have a constant interval with parabolas. Right? All right, so your y-intercepts. Okay, there is, well, we have some calculator steps to get the y-intercept. You can go to graph, trace, 0, enter. So let's write that down. Graph, trace, 0, enter. And then your zeros or your x-intercepts, you can go to second, trace, and then 0. And we're going to use something called blinking bob. So I'm going to put a little BB there and circle it so we remember. That's silly. Blinking bob. Although some people say dancing bob. I don't know. Or blinking bow. I mean, it's just, you know what I mean? Times are changing. We're so sleepy today. We're so sleepy. All right. So the intercepts. All right, guys, let's try out this y-intercept on the calculator, right? We still have it up. Let's go to our calculator here. Go to graph. Let's try this. Trace, 0, enter. 0, 0. It even gives you the x value too, because you have to give me the point, right? So 0, comma, 0. Good. Now, for the zeros, for this one, the x-intercept, unfortunately, your calculator, I was having some issues with the calculator, so we're going to just find it here. Where does this graph cross through or touch the x-axis? 0, 0, right there, right? So that is your x-intercept. 0, 0. But this one is special. This one's actually called a double root. All right? If your graph does not cut through the x-axis, but it looks like it just bounces off of it, it means you have two of the same number there, okay? So this graph, it bounces off of the x-axis at 0. So this means if you were to go solve it, it's x equals 0, x equals 0. Does that make sense? You have that same number twice. All right, so now the end behavior. As x approaches negative infinity, which, like, if you're standing on the x-axis and you want to go towards negative infinity, which way do you have to go? To go to negative? Left, yeah. So then this is asking about the left arm of your graph. Look at your graph. What is the left arm doing? Well, it's going up, right? Yeah. Your only options are up, down, or straight to a number. It's going up to infinity. So then as x approaches infinity, that means we're looking at which arm? The right arm, because that's like saying if you're on the x-axis and you want to go towards infinity. All right, look at your graph. What is the right arm doing? All right, and it's going up as well. Good. Increasing all the way up to infinity. Good. Are they ever going to do different things? No, because a parabola is U-shaped, right? So it's either they're both going up or they're flipped, so they're both going down. Okay? All right, questions about this? Okay. Let's go on to the next page and let's talk about the vertex form. All right, so these are transformations, basically, right? We've talked about these rules. Let's start from the end there. Plus k. Guys, what happens to the graph if I plus a number all the way at the end? How does it move? Plus up. Good, thank you, Mitchell. All right. So if plus k is going up, then what is minus k? Good. All right. Now, let's go on to the middle part there with the x and the parentheses squared, right? How about if we have an x minus h? X minus h. You'd think it would be left, but it's opposite, so you have to go right. Guys, remember, x minus h, so I'm like minus 3, that means you're going right 3. So then x plus h means that you're going how? Good. Left h. So then how about this guy? How about A? A has 3 different jobs. What if it's negative in the front? What is the other thing you can do? Compress, stretch, or... Good. So if you have a negative, then it reflects or it flips. Okay? But if your A number is greater than 1, what does that do? Like you have a 3 or a 2 or something in the front, bigger than 1. Good. Thank you, Jenny. Stretch. How about if your number is between 0 and 1? like 1/2, 1/3. Compress. Thank you. Super. Thanks. Alright. So now you have these graphs, and you have to describe what happened to them from the parent function. Give me the vertex, and then let's write out the new equation. Okay? First off, guys, what is the vertex here? What is that point?
5, 2.
5, 2. Thank you. Where was the vertex for your parent function? The graph that we did way in the beginning. 0, 0. Good, thank you. So if it started at 0, 0, and then it went to 5, 2, guys, how did it move? Like physically, tell me in words. Up to, okay, so, good, good. Up to and right 5. Did this flip? No, it's still U shape. Alright? So now we have to write the function. We have y equals, and then we have the x with the square, right? Okay. So tell me, how do I write the up to? Where does that +2 go? Inside? Outside? Inside? Up to? Where's up to? Outside. That's your k. Up and down is your k, right? +2. But the left and right goes inside the parentheses. If it's right 5, which one is it? X minus or x plus? Minus. So Jenny, just think opposite, okay? With the x's. Guys, I want you to try the next one. Oh, the next one, the one thing that stands out, what did it do? It flipped. So it reflects, but just tell me what that vertex is first, and tell me how it changed from 0, 0. I know I said do this on your own, but what is the vertex? 3, 5. Alright, so we said the reflex and the vertex together. Write down the other transformations, please. Alright, so here is what... Oh, what happened here? Group. Okay. Here's what Peter got. He put the negative in front because it reflected, right? Okay, so there's reflex. Uh-oh, there's right 3. Uh-oh. And then up 5, right? Oh my goodness, okay. Yeah. What's happening? Okay.
What?
Oh no, when I moved it, it got all crazy. Alright. So let's try something a little bit more fun. Guys, so let's look at example 1. Okay? Oh, before we do this. No, you know what? No, let's do this first and then we'll do it. Okay. So go to our calculators and let's put this in the y equals. And remember, this negative in the front is a negative sign, not a minus. Okay, let's put this into our calculator. Alright, so let's graph this and see what it looks like. Okay, does your graph look like mine? Alright, so, let's just keep that there. Let's go back to our sheet. So since this is written in vertex form, we can talk about the transformations here, right? What kind of things happen? What does this +2 at the end mean? Yeah, okay, so it's up to, thank you. Up to. How about this x plus 4? Left 4, good. anymore, and it flips. This negative in the front tells me that it reflects or it flips. All right, so guys, what else can I fill in here? What is always, always, always the case? Domain. Domain is always negative infinity to infinity. Now we can get the vertex. So if I go back to my calculator, look at that. Does it have a max or a min? Max. Okay. So we have to go to second trace. So we want to hit maximum. And where's my blinking bob? Well, if I look at this, my x is at 0 and y is at negative 14. Negative 14 on my y-axis is like way down here. That tells me that's where blinking bob is. So I'm going to hit the left arrow so I can get blinking bob, dancing bob, whatever. Okay? That is what I want, the vertex, right? The maximum. So I'm going to put blinking bob on the maximum, and that is the starting point. Okay? My calculator's saying go to the left. So to the left. 1, 2, 3, 4. You can hit it 3 or 4 times. That's it. Yeah. Okay? And then hit enter. Now, go back to your starting point, and then you have to go to the where? To the right. So to the right. 1, 2, 3, 4. Hit enter. Hit enter again. And there you go. That's the maximum. Negative 3.99999 is negative 4, comma 2. All right? So now, you guys try. Let's try this. Go to graph. So go to second trace. What is it that we're looking for? Maximum or minimum? Maximum. Okay, so let's go down to maximum. Hit enter. Move your blinking bob to its starting point, the maximum. And even if you're not right on it, that's okay. Just get as close as you can. All right? So are we all there? All right. Now, to the left. Hit the left arrow. 1, 2, 3, 4. Yes, Lee. You can do fine. Hit enter. Yeah? Oh, it's okay. You know what? You guys are not going to get the line. You're going to get these triangles up on top. You don't have that? All right. Did you? All right. Let me try it again. Okay. Hit graph. You hit second trace maximum. Remember how I had you guys standing? This is silly. This maximum, that's your starting point. Your calculator's saying hit left. So left. 1, 2, 3, 4. 3 or 4, doesn't matter. Hit enter. Go back to your starting point. Don't hit enter. Now your calculator's saying go to the right. Right. 1, 2, 3, 4. Hit enter. When it says guess, you hit enter again. And there you go. Negative 4, 2. That is your maximum. That is your vertex. Okay? Anyone not get this? Please say something. All right. All right. So negative 4, 2. That's my maximum. So then what does that say about my minimum? None. So if negative 4, 2 is also my maximum, then that's the same as my what? Vertex. Good. And if I know my vertex, what is my axis of symmetry? Good. X equals negative 4. Great job. So guys, once I know my vertex, I can go graph it. Negative 4, 2. And then you know what? Give me 2 points above and 2 points below. Negative 3, negative 2, and negative 6. Oh, and 1. Negative 3 and 1. So how about for negative 2? What's my y number for negative? Oh, negative 2. Okay. All right, so let's graph this. Right? Something like this. Guys, I want the y-intercept. Now, I know we can't see the y-intercept from here, but you know, this graph is going to keep on going, going, going. It's going to hit this y-axis somewhere. Remember, you have calculator steps to find the y-intercept. Do it. Go to your calculator. Hit graph.
0,
negative 14. Trace 0. Enter. Yeah. 0, comma, negative 14. I hope you wrote down these steps on the first page. Yeah. Before we go on to do the x-intercepts, let's do the range. All right. So the range is from the bottom to the top, right? You guys have arrows going down for this graph. Where's it going? Yeah, negative infinity. So from negative infinity all the way to what? Where does this graph stop? 1, 2. And 2 has a closed circle, so this is going to be bracket. Right? All right, so let's get the x-intercepts. Now, these x-intercepts are not very pretty, right? They don't go through a perfect point. I think we're going to have some decimals, right? Okay, so you can get these on the calculator. So there's one right there, and there's another one right there. Yeah, you have 2 x-intercepts or 2 zeros. So go to your calculator again. And you're going to go and get second trace 0. Okay, hit enter. Now we need blinking Bob. Look, right now he's down at y equals negative 14. I gotta hit left until he comes up. Make sure you get blinking Bob up. There we go. I stopped there at that 0 because that's what I want. So that's my starting point. Okay? All right, so your calculator says left. So hit the left arrow. 1, 2, 3. Hit enter. Go back. Yeah, you can do 3 or 4. And then go back to your starting point. And then your calculator says right. So right arrow. 1, 2, 3, or 4. Then hit enter. Hit enter again. You should have this. Negative 2.59. Yeah, we'll round up because it's 85. So negative 2.59, comma 0. Yeah, that's this x-intercept. And then we have another one that we need to find. Right? Did you not get this? If you didn't get this, then please say, okay? No, let's make it a little bit more precise. A little bit. Negative 2.59. Negative 2.59, comma 0. And what's the other one? Let's try it. Second trace 0. Let's find the other one. Move blinking Bob over to the other one. right? Because that's your new starting point. And then you guys find it. Tell me what you get. Try it out. You have to know how to do this. .53 as your y. Your y should be 0. Is there an e in there? So I'm right here, right? Says go to the left. 1, 2, 3. Hit enter. Go to the right. So I'm gonna go back and then go to the right. 1, 2, 3. Hit enter. Hit enter again. So negative 5.41, comma 0. Yeah? You got it? Negative 5.41, comma 0. Yes? All right. I think it's a little bit weird using blinking Bob at first, but you as long as you practice, you'll get it. Let's do the easier end behaviors. Guys, where are these arms going? Yeah, they're both going down. They're going down to negative infinity. All right, so now increasing and decreasing intervals. Where's your axis of symmetry? X equals what? Negative 4. Okay. So at x equals negative 4, so right there, that's where my line goes. Okay. Negative 4. I have an arrow on the left. Where is that going? Yep, negative infinity. I have an arrow on the right. That's going towards infinity. So what is my graph doing from negative infinity to negative 4? Yeah. What's it doing from negative 4 to infinity? Decrease. So there you go. Those are your two intervals. All right? Questions? Okay. So let's try another one then. You want to try number 2? Sure. Okay. All right. So look at number 2. What are the transformations here? There's -2 all the way at the end. What does that tell me? Down 2. Good. Thank you. All right. What about that x minus 4? Huh? Right. Good. Right 4. How about that 1/3? Compress. Good. Perfect. So Peter and Jarvin, we haven't done this one. Number 2. All right. What else can I plug in here? What else do I know? Domain. Domain. Trying to see if anyone's listening. What's going on? Domain. Always. All real numbers. Right? Always. Now, let's go and graph this. Let's see if our vertex is a max or a min. All right, so this is y equals, we have 1/3 x minus 4 minus 2. All right, let's see what this graph looks like. Ooh. right, so my vertex, is it a maximum or is it a minimum? The minimum. Okay, so blinking bob, second trace, minimum. I'm going to move blinking bob over to the minimum because that is my starting point, right? This one, since it compressed, it's like a little bit wider, right? So if you feel like 3 is not enough, you can go to the left and to the right, like 4 or 5, okay? So go to the left, 1, 2, 3, 4, 5. I'm gonna go 5, pretty wide. Hit enter, go back to the beginning, starting point, and then 5. Hit the right arrow, 1, 2, 3, 4, 5. Hit enter. Yeah. And then it says yes, no, hit enter again. Did you get this? Yeah. What is 3.99999? 4, right? So 4 comma negative 2. So my, what was that, a max or a min? 4 comma negative 2, which is the same as my vertex 2. And that means that my max has to be none. My max is none. Oh, I know what you're thinking. Axis of symmetry. What is the axis of symmetry? Not just 4. X equals 4. Guys, I will definitely take off some points if you do not put x equals, okay? Because it is an equation, all right? So if I have 4, negative 2, give me some other points here. You know, and let's go to second graph. 4, negative 2. Do I have to use 3, negative 1.667? No. Go get just the nice points. Go get 1, 1, negative 2, 10. 1, 1, negative 2, 10. That's not to say I'm going to graph negative 2, 10. It's probably off my charts here. That's okay. So then what is this? 2 points below. What are some nice points below? 7, 1, and 10, 10. Good, thank you. So let's go and graph this. And you know, the 10 is just so far up. I can just do this. This is fine. Okay? Alright, so what about the y-intercept? Again, I can get that straight off of the calculator, right? Graph, trace, 0, enter. What is that? 3.33? You can give me the decimal for that. That's fine. Alright? And it's repeating. 0, comma, 3.33 repeating. 3.3 repeating, it doesn't matter. You can just put 3.33, it's fine. Okay, that means that my graph is a little bit off. Alright? Alright, so what about my x-intercepts? Ooh, the zeros. Fun. I have a 0 here, I have a 0 there. Yes? Alright, let's use blinking bob to get our zeros. Graph. Now, second trace 0. Alright. Jarvin, I'm going to move my blinking bob to the starting point, which is the 0 all the way over on the left, right? So now it says, okay, left. Hit left. 1, 2, 3, 4. Hit enter. Go back to your starting point. And then now your calculator is saying hit right. So 1, 2, 3, 4, enter. And it's a guess. We want to hit enter again. And that tells me 1.55, comma 0. Perfect. 1.55, comma 0. Okay, let's go and find the other one. Second trace, 0. I have to move my blinking bob all the way over to the other x-intercept because that is a new starting point. And then to the left, 1, 2, 3, 4, and enter. Go back. To the right. Hit enter. Hit enter again. 6.45, comma 0. Yes? Oh, Alex? Did you get this? You didn't do this one? Did you get the other one though? Okay, try this one. 6.45, comma 0. Alright, so what about the range then? Let's talk about this range. Remember, it starts from the bottom to the top. But it looks like my graph doesn't even start. Where'd it go? Okay, there we go. It looks like it doesn't even start until where? -2. Remember, it's on the y. That would be 4. Okay? Until -2, all the way up to where? Good. -2 in brackets, right? That was actually really cool because usually if I throw something off of the board, it springs back up. Just here. Isn't crazy? Alright, so now what about the end behaviors? What are the arms doing? Are they going up to infinity or down to negative infinity? Up to infinity. Look, they're both going up. So the left one is going up. The right one is also going up. Yeah? Alright, so now the increasing and decreasing. Guys, what was the axis of symmetry? X equals what? 4. Basically where my vertex is, right? So that's at 4. I have an arrow on the left. Where is that going? Left. Negative infinity. To the right? Uh-huh. What is it doing from negative infinity to 4? Good. And then 4 to infinity? Increasing, right? Do you guys notice how if one side is decreasing, the other one's increasing? Or if one side is increasing, the other one has to be decreasing, right? So, increasing from 4 to infinity, decreasing from negative infinity to 4. Yes? Alright, let's try another one. Let's do number 4. This is a great one. Alright, so we need a graph. Let's grab this guy right here into our calculators. And the great thing is, no matter what form it's in, you can plug it all into your calculator. Oh no. And it should all work. Okay? Unless if you don't put it in the calculator correctly. Alright, so tell me something. What is the one thing that I know for sure, always? Domain. Let's fill that in then. Why not? graph this. I want to take a look at it. How pretty. Yeah? So I'm going to go and let's find the vertex here. Is it a max or a min? Min. All right. Second trace minimum. Where's Blinking Bob? I don't see him. He's all the way up at y equals 24. That means he's all the way over here on the right arm. So I'm going to hit left to get him down. Does that make sense? Okay. And so I'm going to go to the starting point, which is at the minimum. All right. You know what? I just realized something. On your calculators, your vertex may be covered by the left bound. Okay, hold on. So your vertex is being covered by the writing. Yes? Okay, let's change the window a little bit, right? Don't you want to see the bottom part just a little bit more? So what you can do is go to Window. All right. Which axis is that if you want to see the bottom? Is it X or Y? The Y. So you don't want the X min or the X max or the X scale. You want the Y's, right? This is saying the smallest Y number is -10. Right now, -10 is not enough. So do you want to make it like -15? Yeah, change that. Just make it -15 for your Y min. It doesn't change anything else. It just makes the bottom part of your graph a little bit longer. So then let's hit enter, or let's hit graph, sorry. Does that help a little bit? Okay, so now, is this a minimum or a maximum, Jose?
A minimum.
Okay, so second trace minimum. Alright? So my Blinking Bob still hasn't come down. Okay, there he is. So I'm going to go to this minimum, and that's my starting point. So from here to the left, 1, 2, 3, 4, hit enter. Go back, and then to the right, 1, 2, 3, 4, hit enter. Enter again. Nice. -4, -8. Yeah? All right. So my minimum, -4, -8, which means that my maximum is what? None. And my minimum is the same as my vertex. And if I know my vertex, I know the axis of symmetry. What is my axis of symmetry? Thank you. X equals -4. Super. So -4, -8. Guys, go to your tables and then give me some more points. 2 above and 2 below. Let's graph this. Huh? 2, 0. Okay, I like that. -2, 0. Sure. Then -6, what? 0. All right. And then what is this? 0? Zero 24. Okay. Then that means -8 24. Oh my goodness. All right. Well, don't try to graph the crazy ones. Just do the -4, -8, -2, 0, and -6, 0. Guys, you know what I love about the intercept form? I don't have to use Blinking Bob to find the zeros. Look at the zeros here, your x-intercepts. Don't they go through at the exact point, -6 and at -2? Right? You have an x-intercept right there, and you have an x-intercept right there. That's because you have your zeros right there. X plus 6 equals 0, x equals -6. X plus 2 equals 0, x equals -2. Those are your x-intercepts. Yeah? Okay. Oh. And what's my y-intercept? Trace 0, enter. Graph. Trace 0, enter. Huh? Did you hit graph? Huh? 24.
24.
Did you say 24?
I got 24.
What? 24. And look, it's right here. 0, 24. Oh no. Do you have the right graph in? Do you have this one in?
Yeah.
Okay. So make sure you get it. Alright, so what about the range for this guy? What do you think? Tell me, where does it start? -8 all the way to what? Good. -8 to infinity. Now, I want you guys to try these. How are the arms going? Left arm, right arm. Up. Okay, they're both going up to infinity. Now the increasing and decreasing. Do you need a few more seconds? Alex, do you have it done? Increasing and decreasing? Yeah? Where did you draw the line? Like the... Okay, -4, because that's your axis of symmetry, right? So at -4. To the left, you have -infinity, and to the right, you have infinity. What is it doing from -infinity to -4? So then that means from -4 to infinity, what's it doing? Increasing. Good. Okay? For number 4, your x-intercepts, they're not going to be real. They're going to be imaginary. Okay? So, here's what you can do. I want you to graph it. I want you to answer everything, that you can. It's all going to be the same. The x-intercept is just going to be not real. But if you want to challenge yourself, go and plug this into that quadratic formula and find the solutions. They're going to have eyes. On Blackboard, I also have the answer key to this homework up so that you guys can check your answers. Okay? If you just copy, I'm going to know because you're going to have a quiz on this, right?
Yes.
All right. So,
Subscribe.
subscribe to my YouTube if you want the videos.